Hello. Welcome to Karmada community meeting. Today is July 22. Okay. Let's get started from the first agenda. Mihashi, you.
Yeah. So the first issue, I think I raised a couple weeks ago now. This is something that we noticed when migrating workloads between clusters during like DR tests. So we would do this via taint-based eviction. So in the example scenario that I provided in the ticket, let's assume that we have three clusters, A, B, and C. And we have 15 applications, each with one replica running on cluster A. Let's simulate a DR event by adding a no execute taint to cluster A. And this will trigger a taint-based eviction, and Karmada will reschedule the 15 workloads to other available clusters. Assuming that we're using the Karmada scheduler estimator, which is what we use in our case, in this scenario, let's say cluster B returns 10 available replicas and cluster C returns 5 available replicas. Ideally, what we want is for Karmada to distribute the 15 applications across B and C. But in practice, what we notice is that given that these the rescheduling is happening in rapid succession, the scheduler estimator results are not updated between each decision. So what ends up happening is each one of those workloads gets the 10 available replicas returned, and all of the replicas get scheduled to cluster B. Even though like there's no way for the scheduler to understand that it has previously just scheduled a couple workloads to cluster B. Let's try to balance it and send a couple to C as well.
Okay.
So, and we think that this isn't just a problem during like cluster failover. If you ever bulk apply a bunch of different applications at once, all of those applications will get scheduled to the same cluster.
Yeah, I see. Actually, I'm very glad you bring this up because I have been thinking of this issue for a while, and I think the problem might be exist in Weicheng use case because when you are trying to deploy a bunch of jobs to Karmada, the estimator will use the let's say use the outdated cache, so the estimation will be not accurate.
Yeah. So we have encountered this. So and we will need to have another scheduler in cluster to handle this, to do like requeuing to handle this case. Yeah.
What? Well, you have another schedule working in where?
Right now, no, but we will need to have another scheduler to handle this because the scheduling is actually pretty fast, and we'll probably need the outdated cache, the outdated cluster information, which if we have if in a given like a small period and there are a bunch of jobs get created, all of them will, like, sometimes they will all get scheduled into the same clusters. However, the actual GPU is actually not enough, so those jobs will be like partially scheduled or will be pending right there. So
Yeah. So your idea is introduce another scheduler.
Yeah, I think currently we are also thinking about the setup of like we're still thinking. I have like maybe using like using the setup that you and Kevin like provide, which have a like a volcano or like another scheduler inside the cluster to handle like against scheduling and avoid any partial scheduling. So and allow it to get requeue inside it. Although it will have some issues such as like if like there might be a lot of job get pendings inside the clusters and the Karmada doesn't know that. So so like if there is a like a latency between job get created and the cache update, it might still like get scheduled to it. So we're still thinking about that.
Yeah.
Yeah.
Yes. Actually, when I update the multiple template scheduling proposal, I was thinking if I need to make the room for this for this problem. Yeah. I think the root cause is very clear that the estimator uses the node cache, but the node cache
Hello?
um, will in general I give the estimator. Hello, I'm lost. Sorry, can you hear me?
I can hear you now. The connection's a little unstable though.
Yeah, I think so. So it takes me 2 minutes to join the meeting. Yeah. Okay. So so I think this is we have a. I think this is a reasonable case we should to resolve. So maybe I will try to explain my idea to solve this in the when we go over the proposal.
Okay. Yeah, I can talk with Wei Cheng about the additional scheduler idea as well. Do you by chance have a design doc for that already or no?
For this,
For the additional scheduler that you're thinking of.
Oh, you mean I'm saying Kevin and Hong Cai have they have several talks about like have a Karmada on federated as act as a federated scheduler and have like Volcano as in cluster scheduler. And we haven't have a design doc. I just like reference it.
I see. Okay. Yeah. The issue with rescheduling for our use case, I mean, we could do that. I would have to handle the edge case though, because we're conserving state between failovers. In the case that there are subsequent failovers of the job, we have to conserve the previous job ID until like the resource itself is healthy. So I think I have a separate ticket even created for that. I should work on that. But yeah, I'm not opposed to rebalancing. We just have to be careful with how the state is conserved between
yeah, yeah. See, sure. So, yeah, I get it. So, basically, the idea is let the estimator know there are a bunch of applications are in the queue to apply to the target memory cluster, so the estimator can should reserve the resource before estimating the next application.
Yeah.
So yeah, okay. Let's talk about at the next at the proposal. Okay.
Yeah, so the next one, I think we had talked about it before. I think we just ended up picking up higher priority proposals first. So this, I can actually link it in the doc if possible. Let's see here. Oh, for
So
some reason I don't have access. Let me post it here then. But this is about the workload anti-affinity feature. So for us, currently in Karmada, there's no way to guarantee that duplicate applications or separately deployed applications are scheduled to different clusters. Primarily due to cases where applications have very, very low tolerance for downtime. So the majority of our applications are okay with the failover time. So they may take between a couple minutes, depending on how large the state is, to come back up after being failed over. But some of our applications cannot be down for more than a couple of seconds. And so in this case, what needs to be done is users actually deploy two duplicate pipelines that are processing the same data so that if one application goes down, then have time to restart that application on a different cluster while another duplicate pipeline continues processing, so that they never have downtime in that case. But the issue here is with Karmada, if you decide to schedule these two applications via the scheduler, Karmada makes no guarantees that those applications will get scheduled to different clusters. And so that's the issue. So if one cluster goes down and both of those active applications are on it, then you end up having downtime, right? Because you don't have that duplicate pipeline running in another cluster somewhere. So what we were considering is adding some sort of workload anti-affinity setting into the propagation policy so that the scheduler can make a decision, okay, given this application has a label X, is there another application with the same label already running in the cluster that I think is feasible? And if it isn't feasible, if a workload with label X is already running there, then we take that cluster out of the feasible list of clusters. So essentially, it would be another like additional plugin, and Karmada would filter out clusters that already have a workload that's running with the same label that you've defined in your propagation policy.
Yeah, I see.
But I've listed out the whole motivation and limitation in this design doc, so maybe we could link it in the community meeting as well. But I remember talking to Kevin a little bit about this, and it seemed like he was on board as well. I kind of just wanted to get some additional eyes on it now because I think it's worth picking up, if not for probably not next release, but I want to get like some eyes on a formal proposal. So would you recommend I create a formal proposal on GitHub and then we can go through the review process there? If this sounds reasonable.
Firstly, I actually I have been I've been thinking of this feature for a while. And not just the anti-affinity. I think we have another use case that workloads need the affinity. So in this case, you need the anti-affinity, but another case another use case I get is they need they need affinity. So I think both the anti-affinity and the affinity need to be considered together. And yeah, so speaking of how to push this feature, I think yeah, with a formal proposal would be fine. So and I'm not sure we have enough bandwidth for this feature for this release. You know, we have a lot of feature planned in this release.
Yeah, no, I expected that. That's not a problem. But I did want to get some eyes on the proposal just so we can start to have conversations about it. I think realistically, our timeline for this isn't super strict, but I think if we could get some reviews on this, we could probably try to fit it in a subsequent release.
Yeah, sure. That makes sense.
Do
So
you know who had the use case for Affinity?
Affinity, yeah. A use case. Let me see if I can just no use case. Oh no, no user story section. So I just leave comments here. No, here. Another use case for Affinity. So you know for the training job the training job gets bigger and bigger. So a job you usually cannot be applied or cannot be running in a single cluster. So we are trying a way to split the job to be running in multiple Kubernetes cluster. So the idea is maybe we can split split a huge training job to some small jobs, then apply all these small jobs. So apply all these small jobs to Karmada, and Karmada try to schedule these jobs. So in this case, here, the reason why we need to split the job ahead of a scheduled process is the way how to split the training job is very complicated. That rely on a lot of parameters that we don't know, we don't get familiar with. So I think that should be done ahead of a scheduler. So the Karmada scheduler are trying to schedule a bunch of small jobs, but all these small jobs trying to schedule these jobs and try to put them in same cluster. So here, when we see affinity, it's like something like the soft affinity, preferred. I think it's preferred.
Yeah.
So let's see if Karmada scheduler can find a Kubernetes cluster can hold all of the small jobs. So the jobs will be scheduled to a single Kubernetes cluster. But if not, the jobs will be spread to maybe 2 or 3 Kubernetes cluster. So the basic idea is the scheduler will try to find at least clusters for the group of jobs.
Mhm. Okay. Yeah, that makes sense to me.
So also, I have heard of another user story for affinity. Let me see. First one. So another story is some application need to be run as close as the other application. For example, an application need to access the database, and it 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 needs to be run as close as the database. So caching caching. Yeah.
Okay. Right. So what I'll do then is add these stories into the proposal, and then I'll publish something.
Okay. Sound good. Sound good.
Great. Thank you so much.
Okay. Let's see this proposal. I think the proposal is ready for review now. So okay, let me see how many people in here. So I think the people on this meeting are all are always enough context for this feature. So I'm not going to go through all the background of this feature. So just dive into the design details. Is that okay?
Sounds good to me.
Yep.
Yeah.
Okay. I think basically this feature will be divided to three parts. First part is the we need to extend the resource interpreter, and we need to introduce another interface. Another let me see this something like this interface. The interface can pass the all of the components from a resource template. So I think that's the base that we can. I think this is the basic thing we need to do first. So after that, we need to consider where the components information needs to be stored. So that's go to the resource binding changes. So I think that's the idea we talked a long time ago, right? We are trying to introduce a components field in the resource binding API, and at the same time, we the components. I think it will be a replacement of the legacy requirement replica requirements and replicas, but no rush. So let's see, they will be coexist for a while, and once the components get ready, I think we can deprecate the legacy fields. Okay. So after this, at least the scheduler can get enough information for the accurate scheduling, and so speaking of this, we currently have three I think three alternatives. So I think we already have the full understanding of why the estimator cannot do the accurate scheduling. That because the interface design the interface now can just accept the one, let's see, one port template requirements. So I think that's the reason, that's the root cause. So Mihashi, are you going to explain a little bit about this approach?
Yes, let's see here. Okay, so I think the point here was essentially just to create an estimate of the total amount of resources that we're going to be scheduling, right? So in the accurate estimator, the way that we calculate what the max replicas or what the number of max replicas is by taking a look at the individual replica resources, and then essentially looking at the either the resource quota that's on the namespace or whatever the total cluster capacity is, and then just dividing that capacity by what the replica resources is. And then that way we get a sort of max replica estimation. But what I'm proposing here is that instead of trying to calculate what the maximum number of replicas should be per component, we can kind of just sum up the available CPU resource, or the replica CPU as well as the replica memory, and then just divide that by the available CPU resource, or the available memory resource. So this is in cases where the components is greater than one. So in that case, like when components is equal to one, it's a pretty trivial calculation, right? We're just taking a look at the total CPU available and the total memory available, and then we're dividing that by the replica footprint. And by taking the minimum of both of those values, we'll get what the maximum number of total replicas is that we can fit on a cluster. Um, when the components is greater than one, it really just turns into an estimation. So instead of trying to find what the total number of each component is that we can fit into a cluster, because that starts to get pretty complicated, we can pretty much just take an estimate where we're looking at the individual replica CPU and the individual replica memory. We take the minimum of that, and then we just multiply that by the total number of components. So I think I give an example of this calculation as well. So here where we have a CRD with total replicas equal to 3. So we have two components. One component has one replica, one CPU, and 2 gigs of memory. And then the second component has two replicas, one CPU, and 1 gig of memory. And so we're trying to estimate what the max replica count will be for a target cluster with a resource quota that has 6 CPU and 8 gigs of memory. So when we take a look at that, the way that this shakes out is we have the one replica plus the one CPU, or times the one CPU for the first component, plus the second component's replicas times its CPU, which equals a total of 3 CPU. And then we have the total memory. So we have the first component's replicas times the memory, plus the second component's replicas times its memory. So that equals, well, I think that was a miscalculation because it should just be 2 gigs. So that should just be 4 gigabytes. So we might have to fix that calculation. But we take those two measurements, and then we take what the max or the total available number of those resources is on the cluster. So in this case, it would be 6 CPU divided by 3, which equals 2, or 8 gigs divided by 4, which also ends up being 2. So in this case, the total number of max replicas would be 2 CRDs. I should actually update this though, because one of those calculations is incorrect. But essentially what I'm proposing is let's sum up what the total footprint is for the entire CRD, and then find how many of those CRDs can fit into the cluster's resources. After that, after the estimate is complete, we can run some sort of decision algorithm to verify that all of the components themselves can fit into a combination of the nodes. So if the verification step returns false, then we return max replicas equal to 0. And if it returns true, then we just return the estimate that we made in the previous step.
Okay. I'm going to ask a question is here we are trying to here the available CPU resource, the that this mean the total number of available CPU resource in a cluster, or just a CPU resource in a node
On the cluster.
on the cluster. So
So during the estimation, we don't even think about like individual nodes just yet. I think that's what the verification step is going to be for.
Okay, so I still cannot sure if I understand. I fully understand this idea, but just feels that if we are trying to sum up the resource requirements for different pod templates, and the estimated results might be not that accurate.
Yes, I mean, it won't, well, if you're just summing up all of the individual components resources, right? Let's say you have two components. One component takes up one CPU, the
Mm-hmm.
other takes up three CPU, right?
Oh, I see. I see.
In
Mm.
that case, you're adding up the component's footprint, right? In total, you're going to have four CPU for one of those CRDs that's scheduled. And then let's say
Mm-hmm.
the cluster itself has 8 CPU available, right? If we do 8 divided by 4, then what we find is we have two total CRDs that we can fit into that cluster, right? Because we're just summing up the individual components' footprint.
Mm-hmm. Okay. I see. I see. Another concern is here we are using a total number of available resource in a cluster. So
Mhm.
um, that brings another concern is if uh, if each node have a limited resource, each node have a limited resource, so the total available resource might be huge, but it
That's
actually
true.
cannot hold a. Yeah, that this can avoid that issue. I think you already mentioned this case. Yeah, already mentioned this case. That that. Do you think this can avoid this issue?
Um, so in this case, we don't even have to use the total cluster resources. We can just use, like, if you're using the resource quota plugin, for instance, um, you
Mm-hmm.
would be using the available amount of resources based off of the resource quota, right? So it would be like the namespace resources instead. So I think we can probably configure like how users want to make that calculation. If we're using the general estimator versus whether we're using um, like the resource quota plugin using the scheduler estimator. Um,
Mm-hmm.
that said, would it make more sense? I can add a comment to the PR and make a
Mm-hmm.
suggestion for making the calculation a bit more clear with the variable naming,
Okay.
since it seems like
Okay.
there's a little confusion
Okay.
there.
Sure. Okay, that sounds great because I also invited some people, including the estimator author and some guys very familiar with the scheduling framework, both in Karmada and Kubernetes. So I think they can that would be helpful for them to fully understand this alternative.
Okay.
Okay, so today I think uh, we are not trying to make a final decision for this proposal. Uh, just have a briefly discussion or introduction. So I think we still need some time for the offline review for this proposal.
Okay,
So
sounds good.
I added another two alternatives to this proposal to demonstrate my idea for this solution. First one is uh, uh, first one is we are not trying to bring another gRPC interface between the scheduler and the estimator. We are trying to do is extend the current request and the response structure. Let's see here, we introduce another field to the request, and at the same time the response will be introduced. Will introduce another field too. So let me see. Let's see ghost structs may be more clear. So basically the request structure introduced a new field, and at the same time the response will introduce another field too. So let me see. Yeah.
Okay, so the max sets idea is very similar to the estimation that we're doing in the first option,
Yeah,
which I think I
actually
agree with.
the same idea in uh, alternative one. So that means the total number of a full CRD. So I think I also explained why. So I think let me see. Let me see. Sorry, hold on. No, not here. So we have a assumption for this proposal that for a workload with multiple pod templates, um, we we assume the workload will be scheduled to just one cluster. We are not trying to split the workload, right? So in that case, the estimator maybe can just estimate if the target cluster can hold the full CRD. But I'm proposing this is a max number of this, because the information will be used by scheduler to maybe sort the cluster.
Yeah.
Yeah, I think the makes sense. The still can sort the cluster by their available capacity for the workloads. So I think let's go move to the also instead in addition to the estimator interface extension, we also need to extend the plugin interface inside the estimator. So currently uh, the plugin still can just accept the one port template. So we need to introduce another interface so it can accept the multiple components. The same idea with the estimator interface. Okay, I want to quickly go through the next next. Sorry. Let me see here. So the another alternative is similar to alternative two, but it requires to introduce a brand new interface between the scheduler and the estimator. So uh, let's see. Let's see the request. So it will have a very clear request and a response. So the interface will not be mixed up with the legacy interface. So in the request, we have components, and the response we have just a max size. So the estimator logic will be very similar to the above one. So I'm not sure if I make it clear. And do you have any questions? It's quite a long proposal. I think it needs some time to.
Yeah, I was going through it a little bit too. I don't have additional questions. What I'll do at least is take a second look at the alternatives, and then I'll also suggest a change to the first alternative just to make the calculations a bit clearer. So I'll put that on my to-do list.
So which one are there?
Yeah, I haven't got a chance to look at like the
Oh,
other alternative. I will check it today.
fine. Okay.
Sorry.
So I will share this proposal at the next community meeting. Next meeting is Asia time. So at that time, I will invite some guy. Let me see. Huh? Oh, here. this guy Gary is the author of estimator, and this guy is very interested in Kubernetes. So I will invite them to that meeting. So I think we can continue to review this proposal on the PR and leave your comments so we can continue discuss it.
Yeah, sounds good.
Oh, okay. One more thing. I think I just forgot to explain my idea to resolve this issue. So let's see this interface. Let's see the background. So the root cause for the estimator cannot maintain the cannot maintain the node cache because the estimator lacks of the context of how many resource it has to reserve. So let's see. An idea in my mind is here for its estimator interface. We can pass the resource requirements for the estimator to reserve. For example, uh, maybe we have another field to represent how many workloads just been scheduled but hasn't not be applied to memory cluster. So in that case, the estimator need to reserve the resource and then to estimate the current application.
Yeah, I agree that reservation will definitely be helpful. I remember like in Kubernetes they have like the nominated no name, and then during the filtering or like scoring stage, like
Mhm.
we'll use that to check how many noted how many pod is already like nominated but doesn't haven't been created yet. So
Yeah.
probably can like utilize the same mechanisms or like the like similar.
Yeah.
Yeah.
Mm. So I've been thinking if we need to make the room for that feature or leave um, or extend the interface next time. So I'm not sure. Okay, I think that's the open question. I will need to consider about this. Maybe we can leave the to make the room in this proposal, and we can uh, implement this feature outside outside next release. So
Yeah.
Right.
Okay. Okay. So, I think. Changjin and Zhang, do you have any comments or?
No, I have no comments now.
Me too.
Okay. Fine. Okay. Generally, speaking of the schedule, I think for now I'm very excited to have this feature included in this release. So at least again, at least I hope to have a MVP version for this feature, and I think at the release, at least we can resolve the second user story, so we can have a accurate the resource quota statistics. So I think that's a great process for the federated resource quota feature. So if no further comments, let's continue discuss on the PR. Okay.
Yeah.
Okay, sounds
Great.
good.
Thank you.
Thanks so much.
Okay. Then see you next time.
See
Yeah.
you.
Take care.
See you.
Okay. See you. Bye.
See you.
Bye.
Bye.
See you. Bye.